Welcome back to our discussion of marine resources. A quick note on the video you just saw on hydraulic fracturing is that even though that was based on hydraulic fracturing on the continent, a lot of those same principles apply to hydraulic fracturing in the ocean. One major notable difference is that a lot of that wastewater just gets dumped directly into the ocean. Okay, moving on from oil and gas. Another physical resource is sand, gravel, and water. Now, these might not be the most glamorous of the resources, but they are nonetheless important and make some people money. Sand and gravel. You may recall from when we were talking about beach replenishment, when we talked about coasts, that sand has to come from somewhere, and usually it's dredged or pumped from offshore out on the continental shelf and then just redeposited back up on the beach. It's actually a pretty big business. The problem is that this really disrupts those ecosystems that are out on the continental shelf because they're essentially destroying those environments. Fresh water is another physical resource. And you may be wondering why we don't do more desalination. You may hear that there's lots of droughts in California and say, hey, why don't we throw up a bunch of desalination plants? Well, the reason is that it is expensive and it takes a lot of energy. Some methods they can use are boiling or freezing. Remember, when we freeze water, it kind of kicks out that salt. Or something called reverse osmosis, where they push that water through a membrane that removes the salt. The problem is that, sure, they're useful in drought conditions, but then as soon as the drought is over, now you have a desalination plant that is really expensive to run, and people are wondering, why are we spending all this money on a desalination plant when now it's raining? Might be a little short-sighted. Anyways, a consequence of desalination is that they have to do something with all that salt. And so the way that they dispose of it is that they pump it back out to sea. And as we saw in that video of the brine pool, those highly saline environments can be really bad for the organisms there. Okay, now we're going to talk about energy resources. And what's great about these is that these are renewable sources. And basically, there is a lot of energy tied up in those waves, winds, and tides in the ocean. And with these energy resources, we are converting that energy into usable electricity. Currently, 7.3% of the electricity in the United States is from wind. And this is a picture of an offshore wind farm. These turbines are converting that wind into electricity. Whoops. Okay, still in development are harnessing waves and tides for energy. And this is more on the prototype scale. On the bottom right, you see this kind of flexible tube. And as the waves go under that tube, it kind of bends and pushes pistons that create energy. So that is something that we're not currently using, but is happening in the future. Okay, biological resources. Seafood. Delicious. Okay, the seafood market is a $159 billion industry, so it's a pretty big deal. Now, when you look at the numbers as far as how much of our actual food supply as on Earth comes from seafood, it doesn't look quite as impressive. 6% of all protein and 17% of all animal protein consumed by humans comes from seafood. And a lot of this is made up by Asian countries where seafood is much more of a staple. And so we're talking specifically about crustaceans, mollusks, and fish. These are our biological resources. Now, most of this we think of is going for human consumption, just plain old seafood. But we're also finding that there are certain organisms that we can harvest that have medical benefits, and then some of them are used for animal feed as well. Now, fishing's changed quite a bit over the years, and it's no longer uh, just a person out in their rowboat with a fishing pole. Now they're catching it with something called a trawl net. And you can see that in this picture to the right, that net being emptied onto um, the deck of a fishing boat. This comes with its own set of consequences. So let's take a little bit of a closer look. Okay, uh, here you see a scale diagram of how big these trawl nets actually are. And so gone are the days of the fishing poles, and in are the days of sonar and a trawl net. You may have heard the expression that, oh, that casts too wide of a net. That expression comes from this idea of trawling, that you kind of pick up everything within that net. So the effects of these trawl nets, they're catching more fish, but they're also absolutely devastating the environment that some of these critters live in. Um, Especially what are called bottom trawls, where in this picture, oh geez, in this picture you can see that this is mainly catching midwater, kind of up in the water column. The bottom trawls just kind of get dragged across the bottom. And it is so disruptive to the environment on the bottom of the ocean that you can see that from satellite pictures. These are areas where bottom trawls have been dragged across the benthic, and so all those benthic organisms are getting scooped up in there, whether or not they are the intended target. So that leads me to the next kind of downside of these trawl nets is something called bycatch. And this is all the stuff that they didn't mean to catch. A formal definition is that bycatch is animals that are unintentionally caught and killed while collecting the target organisms. Unfortunately, that process of extracting them from the ocean usually causes them to die. What's shocking is how much of that haul in that trawl turns out to be bycatch. In U.S. fisheries alone, in 2011, 17% of everything caught in the net was something that they didn't intend to catch. It gets worse when you look at shrimp fisheries, where 80% of the organisms caught in those nets were bycatch. Okay, so a consequence of these newer fishing methods is that obviously we're catching more fish. The negative consequence is that we are fishing at levels that are unsustainable for the world's fish population. So let's spend a little time with this graph from the Food and Agriculture Organization of the United Nations. And basically it's showing some changes in how we fish, or changes to the fish population between 1974 and 2013. And in this chart, we've kind of lumped all the fish in the world into three categories. First, underfished. These are fish that are being fished sustainably. Their populations are okay. And then we have this category called fully fished. And these are, even though those populations are okay, we are pushing them to their maximum limit. And we can't go any farther before those populations decline. The last category, most concerning, is overfished. And this is a category where we have fished so much that those populations are declining, and if we continue on that path, those populations will disappear. And as you can see, this overfished category, it has increased from about 10% up to about 30% between 1974 and 2013. Okay, finally, our last category, non-extractive resources. And remember here, we are getting some benefit from the ocean without actually removing something from it. And so the biggest category of this is transportation. Chances are that if you received a package from Amazon today, whatever product you bought probably spent some time on a cargo ship, because 80% of global trade is happening through marine transportation. Another thing you might not think of as a resource is recreation. So visiting the beach, surfing, jet skiing, whatever you're into, that is considered a marine resource. Um, Also, tourism, real estate, these are resources that we are getting from the ocean. And then finally, a resource that you are consuming right now and maybe not realizing it is education, which is considered a marine resource. Okay, with that, that wraps up our discussion of marine resources. Have a good day or good night, wherever you're watching.